Welcome back, ladies and gentlemen. Today we're going to take a look at 7.3a function operations. Okay, so yeah, we're going to get things rolling here and go from there. All right, so well, basic operations. Okay, so here we're going to start off by saying let f and g be any two functions. A function be something like 2x and x plus 1. A new function h can be defined by performing any of the four basic operations: addition, subtraction, multiplication, and division on f and g. Alright, so it's best to see this in action. Alright, if they tell us we want to create a new function h of g by adding f and g together, look at all that I'm doing. Over here, my f function is 2x, so I'm replacing f of x with 2x. Plus sign. My g function is x plus 1. And right now you're probably thinking it can't be this easy, and it totally is. 2x plus x is 3x, plus 1, you win. Okay, there we go. Now, oh no, what do I do if it's minus? Well, it's the same basic premise. My f of x is 2x. Please be careful of one important thing though. When I subtract, I'm subtracting the entire g function. Make sure you're putting x plus 1 in parentheses because I need to do 2x minus x minus 1, which 2x minus x is positive x and then minus 1. Okay, so again, just subtracting everything. What do you think multiplication is? Well, it's as simple as that sounds. Again, I'm doing 2x times the quantity x plus 1. Again, making sure I have parentheses around my quantity. I can distribute that. So we're getting 2x squared plus 2x. Okay, awesome. And finally, if I'm taking a look at division, please note one little thing here. They tell you that g of x cannot equal 0. Why is that important? Well, you can never divide by 0. Okay, just something that you can't do. So my h of x function, we're looking at f of x goes on top, 2x divided by x plus 1. Hopefully you guys realize I cannot divide those x's because there needs to be a common x in all three terms. So it's simple as it sounds, that's it, boom, done. Okay, so that's basically what we're doing today. Now obviously it's going to get a little more difficult because those are two pretty easy functions. Let's keep on rolling and see what we do. Try the following. They're telling us here that f of x and g of x are the following: x squared plus x minus 6, x minus 2. Yeah, okay, so f of x. If I'm taking a look at f of x, it's x squared plus x minus 6 plus, okay, just bring that plus sign down, g of x is x minus 2. You might be thinking like, oh, up here you kept saying put parentheses around the x, the quantities. Well, if I'm adding, I don't really need the parentheses. Okay, when I subtract, I definitely will. Combine like terms, we are going to see x squared plus 2x minus 8. Okay, done. So simple as can be. F of x times g of x. Alright, so I've got x squared plus x minus 6 times the quantity x minus 2. Here I am dropping the parentheses because I need to distribute. Okay, so I'm looking at x cubed plus x squared minus 6x. That was just me distributing the x across. Minus 2x squared minus 2x plus 12. Okay, combining like terms. X cubed goes out front because we're doing standard form. X squared minus 2x squared is minus x squared minus 8x plus 12. Cool. Okay, ready for your first curveball? Okay, everybody take a deep breath. Alright, so I've got 6 times f of x. Oh no, what do I do? Well, up here, I'm going to write 6. Let me just put a little line going down here so that you guys don't get confused. Okay, so I'm going to do 6 times my f of x is x squared plus x minus 6. Parentheses are your best friend in math. Like, they're there to help you organize, so don't be afraid of them. Minus 2, and my g of x function is x minus 2. Okay? Now I'm going to distribute that 6 across, and I'm going to get 6x squared plus 6x minus 36 minus 2x plus 4. Okay. Okay, so now I'm just combining like terms. I've got my 6x squared. 6x minus 2x is positive 4x. And then negative 36 plus 4 is negative 32. Okay, very good. Alright, this says, I know it's kind of hard to see in paper, but f of x divided by g of x. Okay, this is a tricky one. So what you would have is x squared plus x minus 6 divided by x minus 2. And normally you'd be like, okay, I'm done. But on top, this is a trinomial. You guys are all getting towards the end of the year now. You got to start thinking towards higher math classes. This is something that you're going to get to a lot in pre-calc. I want to try to factor this. So what numbers multiply give me negative 6 but add to 1? Alright, so we're looking at 3 and negative 2. So on top, that x squared plus x minus 6 turns into x plus 3, x minus 2, divided by x minus 2. Now why is that important? Do you notice anything on top and on bottom that's similar? Well, yes, I have an x minus 2 on top and bottom. So kind of think of like if this was 5 and this is 5, 5 divided by 5 is 1. So these turn into 1 and 1, so my final answer is just x plus 3. This is important. This is where we're heading. This is where we're going. So make sure you get comfortable with this, okay? Finally, 3 parentheses f of x minus g of x. Okay, so you write it just like you see it, 3 bracket, x squared plus x minus 6 minus g of x is x minus 2. Okay, so I'm looking at 3 bracket x squared plus x minus 6 minus x plus 2. 3 bracket x squared, x minus x cancels out, negative 6 plus 2 is negative 4. Okay, one last cleanup, distribute the 3 in, 3x squared minus 12. There's a weird box, sorry. Cool. Alrighty. So, I mean, so far, taking a look at this, you're doing nothing different than what you've done so far in class. You're just simple operations, okay? Combining like terms, distributing, so on and so forth, okay? Okay. So we talked about this the first month of school. I don't know if you guys can remember, but we talked about parabolas, and I said, oh, how far left can this go? How far right can this go? And when I asked you about domain, the domain of a parabola was always negative infinity to positive infinity, because it would go left forever and it would go right forever. Well, now we're going to be taking a look at some graphs that don't always go negative infinity to positive infinity. So the domain of a function is a set of x values where the function exists. Here's the graph of f of x equals square root of x. We will shade the part of the x-axis where the graph exists. Okay, so here's my graph. It starts right here, okay, and it goes to the right. All right, okay. So taking a look at that, I'm jumping down here to the following. Okay, on a number line, you are starting at 0. Okay, so here's my number line, closed in circle, and everything to the right. Now in interval notation, we haven't done this in a while, so we're going to have to take some time to get good at this again. You are starting at 0. Can I have a 0? Meaning, is it a filled in circle or like open circle? Hopefully you guys can see that it does exist there. Because it exists there, we're going to use a bracket. 0. And how far right does this go? It goes all the way to positive infinity. Okay? We use a bracket if it exists. We use a parenthesis if it doesn't exist or you can't reach it. So for infinity, you can never actually reach infinity. Hence we use a parenthesis. Okay. Here is a set graph of g of x equals 1 over x minus 2. Now, this is the first time you guys are experiencing this. You're going to see a lot of this as the rest of this year goes on. This right here is called an asymptote. Asymptote. Okay. So what that means, you have an asymptote at x equals 2. Basically what that means, if I put 2 into this function, why doesn't it exist? Well, 1 divided by, if I put a 2 in, 2 minus 2 is 0. You can't have it. So you can have everything all the way up to 2, but you can't have 2. So on the number line, it's going to look kind of weird. Here's 2, open circle. You can have everything to the left and you can have everything to the right, but you cannot have a 2. So we write that. This is a new one for you, so bear with me. You're starting at negative infinity. You're going all the way up to positive 2, but I cannot have 2. So hence I use a parentheses. But I want to join that with, union that. We use this little U here stands for union. Okay? You can pick up from 2 and go all the way to positive infinity. You might be thinking, well, what the heck? Why would I do that? Well, there's actually an infinite amount of numbers from 1 to 2 or from 2 to 3, so you want to make sure you include them. That's why we use this. Okay? And oh geez, I didn't mean to give away the big reveal here. I'm so sorry. How far left does this graph go? Well, it goes to the left forever and ever. How far right does this graph go? It goes to the right forever and ever. So as far as my number line goes, you can have every single thing that you want on there, and you're all good. So my interval notation is negative infinity, positive infinity, and you're all good. Okay? So, just a real basic start to writing out domain. We're going to do a lot more of this. Keep it to go work, and as always, good luck. We're all counting on you.